In classification of heterocyclic compounds, there are two methods. We can classify them heterocyclic compounds by the size of the ring and also their nature, whether they are aromatic or non-aromatic. So first, very important one is we have to see the classification based on size of the ring. Size of the ring. It means how many atoms or elements present in the ring. Size of the atoms. Size of the rings. Okay. Here, if I consider this is first method, one. The first one is minimum we should have three elements to form a ring. That's why first one is three-membered heterocyclic ring. Three-membered heterocyclic compounds. HCC, I am writing it in short form abbreviation. Three-membered heterocyclic ring. You see, in three-member heterocyclic rings, the ring has to be made up of three atoms. So at least one must be the our heteroatom. For example, yes, this one. This one is known as oxyrane. Oxyrane. This is a oxygen heterocyclic compound. And if you have nitrogen, this is aziridine. Aziridine. The same way, we can also have sulfur. This is thiorane. Thyrane. Thyrane, not thiorane, thyrane. Okay. So these are three-membered heterocyclic compounds. The same second one, that is four-membered heterocyclic compounds. Four-membered heterocyclic compounds. So here the heterocyclic ring is made up of four atoms, the one of which, at least one of which, should be the heteroatoms. For example, the nitrogen heterocyclic compound, this is azitidine. Azitidine. The same oxygen. This one is oxetane. Oxetane. Same way for sulfur. Thietane. Thietane. These are four-membered heterocyclic compounds. The third one is five-membered heterocyclic compounds. So here now, for example, from now onwards, we can see the aromatic heterocyclic compounds also. These all are aliphatic or alicyclic heterocyclic compounds. So here, this is one of the very important heterocyclic compound. This is known as pyrrole. Pyrrole. And its aliphatic version, that is, this one is pyrrolidine. Pyrrolidine. And oxygen, this one is known as furan. This is also very important compound we are discussing in this chapter. And its aliphatic version, oxolane. Oxolane. For sulfur, this one is known as thiophene. Thiophene. And its aliphatic version, thiolane. Thiolane. So most of these aromatic heterocyclic compounds are very important because they are more stable. So that's why we'll study in further details. The fourth class is six-membered heterocyclic compounds. Six-membered heterocyclic compounds. Here the heterocyclic ring is made up of 6 atoms. At least one should be the heteroatom. For example, the important compound we are discussing in this chapter is six-membered. Okay, this one. This is known as pyridine. Pyridine. And it's a aliphatic version. Piperidine or piperidine. Piperidine or piperidine. And one more important one, that is oxygen. Not we are discussing in this chapter, but this is also we have seen in glucose structure. That's why it is pyran. So this pyranose ring we see glucopyranose, the Howard structure of glucose. In this pyran we see in fructofuranose, that is in the furan Howard. Sorry, that is in the fructose Howard structure. So these are also involved in biomolecules. And this oxolane is also actually known as THF, tetrahydrofuran, which is also one of the very good solvent, especially in spectroscopy. We use that NMR, we use that solvent. So this pyridine is also solvent. So and THF, and most of these compounds have definitely industrial applications. So these are the primary, and you can also classify them as six-membered, seven-membered. So this six-membered, seven-membered, eight-membered. So it goes on. But especially this five-membered and six-membered have a lot of applications, and these are very important heterocyclic compounds. So that's why we discuss these compounds in detail in this chapter, especially these aromatic heterocyclic compounds like pyrrole, furan, thiophene, piperidine. These four compounds we are discussing in this chapter in details. And the second, so this is the classification based on the size of the ring: three-membered, four-membered, five-membered, six-membered. You can also seven, eight. It doesn't worry. But in your exams, usually these things are very important. Those may ask. And there is one special heterocyclic compound in based on this size of the ring, that is fused heterocyclic compounds. Fused heterocyclic compounds. It is also known as condensed heterocyclic compound. As name itself tells us that heterocyclic compound is fused with other rings. So here this heterocyclic compound is fused with other ring. Fused with other rings. For example, you can see here this pyrrole is going to be fused with benzene, and this pyridine is also going to be fused with benzene. Let's see that. For example, benzene, to which this pyrrole has been fused. This compound is known as indole, and here benzene, to which six-member. Okay. So this one pyridine has been fused. This one is known as quinoline. Quinoline. So this is a special class in heterocyclic compound that has been asked many times. What are fused or condensed heterocyclic compound? Give an example. So this three-membered, four-membered, five-membered, six-membered fused heterocyclic compound. You can also write seven-membered if you, but it's okay. Usually five-membered and six-members are very important, because especially those aromatic ones, and those are also very important. And in this chapter, we are going to study in detail about pyrrole, furan, thiophene, and pyridine. And the second method for the classification of heterocyclic compounds, that is based on whether they are aromatic or not, non-aromatic. Non-aromatic. Based on the structure itself, you can see whether they are aromatic or aliphatic. So here it is aliphatic or alicyclic. It is also aliphatic. It is also aliphatic. Aliphatic, 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 aliphatic. These all are aliphatic. So these we can classify as aliphatic heterocyclic compounds. And these pyrrole, furan, thiophene, pyridine, pyran, these all are aromatic heterocyclic compounds. We can just write based on their nature, we can classify them. So this is about the classification of heterocyclic compounds. Thank you, and I hope you all got it. And please like the video and share with your friends and subscribe to my channel. Thank you.